Welcome to episode 20 of my calculus series. Today, we're diving into trigonometric integrals, those involving powers and products of sine, cosine, tangent, and secant. But before we get into it, if you're enjoying these episodes, a like, follow on TikTok, or a subscribe on YouTube would really help me keep making more lessons like this. Alright, let's get started. Trigonometric integrals are integrals that involve powers and products of trigonometric functions, things like sine, cosine, tangent, and secant. To solve them, we often use trigonometric identities and substitution to rewrite them into forms that are easier to integrate. We typically see three main types: powers of sine and cosine. For example, the integral of sine to the power m times cosine to the power n, with respect to x. Powers of secant and tangent. The integral of secant to the m times tangent to the n. Powers of cosecant and cotangent. The integral of cosecant to the m times cotangent to the n. The strategy changes depending on whether the powers are odd or even. Strategies for sine to the m times cosine to the n. If m is odd, save one sine factor, replace sine squared x with 1 minus cosine squared x, then use u substitution with u equals cosine x. If n is odd, save one cosine factor, replace cosine squared x with 1 minus sine squared x, then substitute u equals sine x. If both powers are even, use the half-angle formulas. Sine squared x equals 1 minus cosine of 2x over 2, and cosine squared x equals 1 plus cosine of 2x over 2. Strategies for secant to the m times tangent to the n. If n is odd, save a sec x tan x factor, replace sec squared x with 1 plus tan squared x, then substitute u equals sec x. If m is even, save a sec squared x factor, replace tan squared x with sec squared x minus 1, then substitute u equals tan x. Strategies for cosecant to the m times cotangent to the n. If n is odd, save a csc x cot x factor, replace csc squared x with 1 plus cot squared x, then substitute u equals csc x. If m is even, save a csc squared x factor, replace cot squared x with csc squared x minus 1, then substitute u equals cot x. Key identities to remember: 1 plus tan squared x equals sec squared x. 1 plus cot squared x equals csc squared x. Sine squared x plus cosine squared x equals 1. Sine of 2x equals 2 sine x cosine x. Cosine of 2x equals cosine squared x minus sine squared x. Example 1. Evaluate the integral of sine cubed x times cosine squared x. Step 1. Split sine cubed into sine squared times sine. Step 2. Replace sine squared x with 1 minus cosine squared x. Step 3. Let u equal cosine x, and du equals negative sine x dx. We get negative integral of 1 minus u squared, times u squared, du. That's negative integral of u squared minus u to the fourth. Integrating. Negative of 1/3 u cubed minus 1/5 u to the fifth. Simplify. Negative cosine cubed x over 3, plus cosine to the fifth x over 5, plus c. Example 2. Evaluate the integral of sec to the fourth x times tan squared x. Step 1. Write sec to the fourth x as sec squared x times sec squared x. Step 2. Let u equal tan x, du equals sec squared x dx. We have integral of 1 plus u squared, times u squared, du. That's integral of u squared plus u to the fourth. Integrating. U cubed over 3, plus u to the fifth over 5, plus c back substitute. Tan cubed x over 3, plus tan to the fifth x over 5, plus c. Example 3. Evaluate the integral of sine of 3x times cosine of 2x. Step 1. Use the product to sum identity. Sine a cosine b equals 1/2 times sine of a plus b, plus sine of a minus b, that's 1/2 times sine of 5x plus sine of x. Step 2. Integrate. 1/2 times negative cosine of 5x over 5, minus cosine x. Final answer. Negative cosine of 5x over 10, minus cosine x over 2, plus c. Summary. Identify the type of trig functions and their powers. Apply the right identity based on whether powers are odd or even. Use substitution to reduce to a basic integral. For even powers, use half-angle identities. Mastering these strategies makes trigonometric integrals far more approachable. And that wraps up today's episode. If this lesson helped you out, don't forget to like, follow, or subscribe so you don't miss the next part of the series. See you in the next one.